I want to take a look at some real-world applications of absolute value inequalities and how we can use absolute value inequalities to express really familiar situations. So in this example, we have a good rule of thumb about speed limits. If our speed limit is 60 miles an hour, we want to stay within 10% of that speed limit. No one is expecting you to maintain 60 miles an hour at all times, but you don't want to go too fast or too slow as you become a danger to everyone else on the road. So in order to get started, let's begin by looking at our 60 miles an hour. Now, anybody in any 7th grade math class and beyond would know that if I wanted to take 10% of 60, that would just be the number 6. So ideally, I am between the numbers 66 and 54, and I'm in this space anywhere is reasonable. Now, that would be a compound inequality. 54 is less than or equal to x, which is less than or equal to 66. Now, if we're going to write this with an absolute value as a contrast, this number 6 ends up being very important in terms of the writing, because it's that 6 that serves as the difference between what we're actually going and what we need to be. So let's use the absolute value to create this same exact compound inequality. We're going to begin with the absolute value bars. We know that it's going to be a less than or equal to, and we know that we're going to be measuring our distance between our speed, the difference between our speed and 60 miles an hour. That's what we want to keep under 6 miles an hour. Now, if you were to separate this into two different inequalities and attempt to solve this, you would see that you would get the two parts of the compound inequality that we already drew. This would give you the 66 part, and this one would give you the 54 part, but a slightly different perspective. We want our distance between our speed and 60 miles an hour to stay below 6 miles an hour. And I shouldn't say below or equal to 6 miles an hour. One more time, we want our speed, represented by x, and the 60 miles an hour, the difference/distance between the two of them. We really should call it distance because we put the absolute value bars around it. The distance between the two of those to be at most 6 miles an hour. Any situation where you're trying to create those outside bounds, the absolute value is really helpful because the absolute value has that unique characteristic of turning everything positive, of course with the exception of 0, but turning everything positive where you get that actual distance measurement and not just some subtraction between the two of them. Similar example here, we have presentations at a local conference should be about 10 minutes. But you can be within 30 seconds of that requirement. Now, we don't want to mix together the 10 and the 30. That would make it look like the presentation could be anywhere from negative 20 minutes long to 40 minutes long. But instead, we know that 30 seconds is really just half a minute. And we could represent that with either a fraction or a decimal. It's not picky in this situation. But different in this example is represent all the times for the presentations that are not allowed. So again, common sense approach says, here's 10.5, here's 9.5. I'm allowed anything in this space, therefore I am not allowed anything outside of this space. I want to maintain between 9.5 and 10.5. Well, if we were to write this similar to how we wrote the last example, we would say, again, absolute value for distance. The distance between our time and the agreed upon time needed to stay within 5 seconds. But we're not looking for that. In this situation, we're looking for more of that or look. We're looking for outside 10.5 and outside 9.5. Fortunately for us, with the absolute value, it's one minor little change. Let's get that inequality going the other direction. And now if I was to split, you would see how we would get our two solutions and create our two different directions for the compound inequality. Careful reading of the question, understanding that the absolute value is a distance calculation, and understanding that you can shift that distance. Like, When you first learned the absolute value, you learned that this was a number's distance from 0. But as soon as you downshift it somewhere else, now this is going to talk about, for example, its distance from 3, or its distance from 10, or a number's distance from 60. All that's happening is you're moving that distance. And this jives with our understanding of graphs. We know minus inside of a function moves a graph right and left, or excuse me, to the right. This does the same thing. This shifts the whole absolute value calculation, so it goes to around 10. Simply a different way of looking at a situation. Here, compound inequalities, different strategy for looking at that very similar kind of calculation.